Okay guys, let's start with case number 1, token hijacking via PDF file. What I want to present to you in this case is how you can hack the web applications with PDF files. This is a really great attack because PDF files are everywhere. They are ubiquitous. So now imagine that you can upload a malicious PDF file to the web application, and then somehow magically you can steal a token of the user as a result of processing of this malicious PDF file. That's gonna be a great and powerful attack. And this is exactly what I want to present to you here. So I've got a demo, and the demo for this case is located at training.local/token hijacking in my testing environment. So let me go there right now and let me show you how this attack works in practice. Okay, here is my demo for this case. And what this demo is all about, it is actually about uploading a PDF file, and I just want to upload here actually a malicious PDF file, okay? And this case is about token hijacking via PDF file. And so the question right now is, what kind of token I am talking about? Let me tell you more about the context of this demo here, okay? And then it will be more clear. So what I've got here is the user that is authenticated to the web application. The web application is hosted on the domain training.local, and what you can see right now in the URL is training.local/profile.php. And indeed, as you can see, there is a user Michael. The Michael is right now logged in to this web application. And what you can find out in the source code of this page is the anti-CSRF token. Anti-CSRF token is used to prevent from the so-called cross-site request forgery attack. That's why something like this needs to be actually implemented in our web applications. And I'm not going to go into the details of cross-site request forgery attack. This is a kind of basic stuff, and I assume that you know what it is. But let me right now just show you that indeed anti-CSRF token is out there in the source code, okay? So let me go to the page source right now. And as you can see in the line number 26, there is input type hidden, name anti-CSRF, and there is a value of this anti-CSRF token, okay? So great. Indeed, the anti-CSRF token is out there, and my goal is to steal the value of this token from the user. The user is Michael, and in order to steal the value of this token, I'm gonna upload a malicious PDF file to the web application, okay? And before I proceed with this case, I just want to tell you why token hijacking is interesting here. Well, the anti-CSRF token is a sensitive piece of data. If I can steal somehow this anti-CSRF token, and in this case, I'm gonna do it via PDF file, then I can actually launch CSRF attack against this user, and this is what I want to do, okay? And the CSRF attack is cross-site request forgery. So it does make a sense to do an attack like this, token hijacking via PDF file, okay? Great. So far, so good. So what I'm about to do is uploading a malicious PDF file to the web application. And now let me show you how this malicious PDF file looks like and what it is actually going to do, okay? So let me go here to the console, and in my testing environment at the location var www training attacker, I've got my malicious PDF file, and this malicious PDF file is token hijacking PDF. So let me open right now this file, and actually let me show you the content of this file, okay? Because this is what I want to discuss with you. So what you can see inside of this malicious PDF file is something like this. script content type application X form calc. So what we can do actually is attackers, is we can include the script inside the PDF file. And this is going to be really interesting. And the way of how we can do it is using the so-called X-form calc, okay? So there is something called X-form calc scripting, and this is gonna be really powerful once it is used by the attacker, okay? And in a couple of minutes, you will see actually how it works. So basically, we can put our own scripts inside the PDF files via the so-called X-form calc scripting. Great. And now I've got here a malicious script that is doing something interesting. Let me right now read the following lines of the code. So there is a line var content get training.local/profile.php. So what this line is going to do is actually reading the page profile.php, right? Reading the HTML code of this page, right? So this is what I am about to do here. And the HTML code of this page, so of training.local/profile.php, is going to be stored in the variable named content. And now you can ask the question, why am I doing this? Well, my goal behind this attack is to steal the anti-CSRF token of the user, right? A couple of minutes ago, I presented to you the HTML code of training.local/profile.php. Out there is the anti-CSRF token of the victim, so I just want to use my malicious PDF file to read the HTML code of profile.php, because out there is the anti-CSRF token of the victim, and this is actually what I am about to steal as a result of this attack, okay? That's why this attack is called token hijacking via a PDF file. Great. So this is the first thing that I am about to do. And the next thing that I am about to do is specified in the next line actually. So there is something like post attacker.local/log.php, content. So once the HTML code of profile.php has been read and stored in the variable named content, then I want the content of this variable, so the content of the variable named content, I want to send it out to the attacker, right? To the domain attacker.local, to the resource actually log.php. So I want just to, transmit this HTML code of profile.php to the attacker control domain. And this is exactly what I'm doing here in this line of code, okay? So this is basically how this malicious PDF file is going to work, okay? And I believe that this is clear for you. And the next thing that I want to do is actually I want to present to you that this attack really works. And it turns out that this attack works in Internet Explorer and Acrobat Reader. So this kind of combination. And later on I will explain you more why it works in Internet Explorer and Acrobat Reader. But right now I want to show you that it is indeed possible to launch this attack in Internet Explorer and Acrobat Reader, okay? So my testing environment is based on Linux. So right now I'm going to go to another VM, Windows-based VM. Out there, I've got Internet Explorer, I've got Acrobat Reader, and in that separate Windows-based virtual machine, I will connect to my testing environment for this case, and I'm going to show you step by step how this attack works, okay? So let me right now go to this Windows-based virtual machine, and let me show you step by step how this attack works. This is my Windows-based virtual machine, and first I'm going to connect to my testing environment where my demo is actually located. So let me put here training.local/token hijacking, okay? Okay, great. So right now I am connected to my testing environment. This is my demo, exactly the same that I presented to you a couple of minutes ago in the Linux based environment, okay? So now I just want to upload this malicious PDF file. So let me click browse. And what you can see here is that I've got this file, token hijacking, already on this Windows-based virtual machine. Well, this is exactly the same file that I presented to you a couple of minutes ago in this Linux-based testing environment, okay? I presented to you actually step by step what is malicious in this file, right? I presented the content of this file, and actually before recording this video, I copied this file from my VM with Linux-based testing environment to this VM with Windows, okay? So this is exactly the same file that I discussed already. So nothing new here. I'm just about to upload this file right now to the web application. So let me click upload PDF. And what you can see is that the file has been successfully uploaded and it is available here. Well, here there is a link behind this word here. And now I want to go to this location, right? I want to go to this location where this file is uploaded, and I'm gonna show you that this attack, token hijacking via PDF file, is really working nice. Of course, here I'm presenting this attack to you. In a real attack, you are going to send a link to this malicious uploaded PDF file to the victim, okay? And the victim is going to actually go to this resource. I mean, the victim is going to click this link to the malicious uploaded PDF file, okay? So let me remind you the context. The context is that there is a user called Michael. Michael is logged in to the web application hosted on the domain training.local. Right now you can see training.local/profile.php. So, well, indeed, Michael is authenticated, and now it's time to present the attack, actually step by step in practice. So I'm going to copy the link to this malicious PDF file, right? And now, in order to show you step by step how it works, I'm going to paste this link in a separate window. Let it be here. And what I want to do also is I want to open DevTools in Internet Explorer, because I want to show you what is actually going to happen in the background once this link is actually clicked by the user, or once the user goes to this malicious uploaded PDF file, okay? So let me open the DevTools and let me start capturing the network traffic, okay? And now let me paste here in the URL bar the link to this malicious PDF file. You can see training.local token hijacking uploads, then we've got some random characters, token hijacking.pdf. So this is my malicious uploaded PDF file. Now I'm going to hit enter, okay? And what you can see is, well, something strange or unexpected, let's say. Script failed. Well, there is a reason why this script failed at this particular moment. So I'm going to click OK and I will explain it to you, okay? So the reason why this script failed is because it has been blocked by Acrobat Reader. Please take a look at this message provided by Acrobat Reader. Data from this site is blocked to avoid potential security risks. If you trust this document, add the host training.local to privileged locations in enhanced security preferences to receive data. Well, if you trust this web application hosted on the domain training.local, and you are a classical user of the web application, okay, then when you see that there is a PDF file out there and you just want to read this PDF file from your trusted domain, training.local, okay, then you're gonna go here to the options and you're gonna click add host to privileged locations, right? This is what classical users are gonna do. We are security people and we are aware of these risks and these warnings, but well, the reality is like this. The classical user, when the user trusts a web application hosted on a given domain, then if the user wants to see this PDF file, then the user will click add host to privileged locations, right? This is what's gonna happen in reality. And now let me do it. And I want you to analyze later on the outgoing traffic from my browser actually, once I click this add host to privileged locations, okay? So let me do it. And please notice what actually happened out there. I mean, what you can see in this network tab of DevTools in Internet Explorer is actually the traffic generated by my browser. And in this traffic, you can see one really interesting outgoing request. There is a request going out to attacker.local/log.php. So this is actually what my attack is all about. Do you remember the content of this malicious PDF file? I was about to steal the HTML code of training.local/profile.php, and I was about to send out this HTML code to attacker.local/log.php, okay? That's why you see this stuff here. And it actually proves that my attack has been successful. And now let me show you that, well, indeed, it is true. So now I'm going to click this guy and I'm going to actually present to you the request body, okay? There is some kind of problem reading this document, but well, actually it is not a problem for me because my attack has been launched successfully. And let me go right now to the request body. And this is the request body of the request going out to attacker.local/log.php. And what you can see out there is actually the HTML code of training.local/profile.php. Can you see that? There is profile, the name is Michael, right? We see also the email of the Michael. And down below, you can see input type hidden, name anti-CSRF, and the value of the anti-CSRF token. So indeed, as you can see, I was able to steal the HTML code of training.local/profile.php. This HTML code has been sent to the attacker as a result of processing of this malicious PDF file. And well, I achieved actually what I wanted to achieve, okay? So it shows you actually the power of this attack. And of course, the assumption here is that the victim, so Michael, is authenticated to the web application hosted on the domain training.local. I presented to you the profile of this user. So the user was logged in. Once the user is logged in, out there is the anti-CSRF token. So actually, this is what must be happening out there, right? The user is authenticated. Once the user is authenticated, out there is the anti-CSRF token of this user, and I just want to steal this anti-CSRF token, okay? So this is a kind of, let's say, a prerequisite to this attack, right? Great. So as you can see, this attack works really nice. And now let me go to the slides and let me wrap up what I have presented to you in this case, okay? So the first thing that I told you is that scripts can be included in PDF files. And I told you that you can use the so-called Xform calc scripting to make it happen, okay? And next, I actually uploaded a malicious PDF file to my demo web application. I explained to you step by step what this file is all about, what is going on out there as a result of processing of this malicious PDF file. Then the PDF file was actually visited by the user. And well, we actually, attackers, need to send a link to this uploaded malicious PDF file to the user, right? This is how it works. And then once this PDF file is actually visited by the user, then the script included in this malicious PDF file reads the HTML code of training.local/profile.php and sends this code to the attacker. And as I presented to you, inside is a user's anti-CSRF token in this code. And yeah, this was my goal, right? And as I presented to you, it is indeed possible to hijack a user's anti-CSRF token via a PDF file. And I presented this attack in Internet Explorer in combination with Acrobat Reader, okay? So this is it. As you can see, really, really powerful attack. And due to the popularity of PDFs, due to the fact that PDFs are ubiquitous, you can actually launch this attack on many different websites. And finally, let me tell you why this attack actually works in Internet Explorer together with Acrobat Reader, because this is also interesting here. Well, when you are about to read the PDF file in Internet Explorer, then Internet Explorer delegates this responsibility, so the responsibility to actually read this PDF file, to the external program, okay? And if you've got Acrobat Reader installed on your machine, then this is this external program that is going to be used to read this PDF file, okay? And Acrobat Reader has implemented Xform calc scripting, okay? And that's actually the reason why this attack works. Now, let me tell you why this attack doesn't work, for example, in Google Chrome. Well, Google Chrome works a little bit differently in terms of the processing of PDF files. When you want to open or you want to just read the PDF file in Google Chrome, then Google Chrome delegates the responsibility of reading this PDF file to Google Chrome's plugin. So Google Chrome has its own plugin to read the PDFs, okay? And in this plugin, the Xform calc scripting is not implemented. And that's the reason actually why this attack is not working in Google Chrome. So as you can see, we've got exploitation that is dependent actually on the software that you are using, right? So here we are talking about the browser and the differences in browsers in the context of how they actually handle the processing of PDF files, okay? So just to summarize once again why it works in Internet Explorer and Acrobat Reader. Internet Explorer is about to read the PDF file. Then what Internet Explorer is doing is delegating this responsibility of reading this PDF file to the external program. The external program on my machine is Acrobat Reader. Acrobat Reader has implemented Xform calc scripting, so we can actually use Xform calc scripting to launch our attack, which is token hijacking via malicious PDF file, okay? So this is the explanation. So I believe, guys, that this is clear for you right now, and I believe that this is informative for you. And yeah, we are done with this case. So let me right now jump to the next one.